Well, welcome to this hybrid event arranged by the IET's Anglian Coastal Local Network, which represents members in North Essex, Norfolk and Suffolk. Welcome to you in the local audience here in the atrium at the University of Suffolk. It's really good to be able to meet face to face. Welcome also to folks joining via Zoom from other parts of the UK and indeed globally. I'm Kevin Foster, I'm Chairman of the Anglian Coastal Local Network, and I'll be your host for this evening. Now, there are a few things I'd like to point out before I introduce our speaker, mainly for admin purposes. We've got an OWL microphone here and camera in the lecture theatre, and it's optimised as far as we can. The camera has a 360-degree lens, and it follows the voice of the speaker. However, it sometimes picks up background noise and speech, and it can be a little bit distracting in Zoom as it flicks back and forth. Hopefully it does not happen tonight, but if it does, I'm afraid there's not much we can do about it, so I'm keeping my fingers crossed. Now, we'll take questions at the end of the talk. We'll take questions via Zoom Q&A, as well as live here in the atrium. So for those online, if you have a question, please use the Q&A panel in Zoom and not the chat panel. On Zoom, please don't try and raise your hands during the talk, because we find it quite difficult to respond to those. So just to repeat, for Zoom, if you've got a question, just wiggle your mouse at the bottom of the screen and you'll see the Zoom taskbar. And you can select either Q&A or chat. So please use Q&A for any questions you have. And that's how we'll pick them out from the Zoom session. So the webinar will be recorded, and CPD certificates will be available via our community site. So finally, there are no scheduled fire drills. If the alarm sounds, we will exit swiftly, guided by our University of Suffolk colleagues. So I'll be looking to you, Mark. Okay, I think that's all the admin over. So without further ado, I'm delighted to introduce our speaker, Andy Fiddler from BT. Andy is a principal architect and distinguished engineer. He's over 25 years experience in covering network architecture, solution design, standards, and industry alliance engagement across satellite, mobile, wireless LAN, and broadband technologies. His current projects include the development and strategic direction of BT's Internet of Things network architecture and aspects relating to emerging network applications and protocols. And he holds a B.Eng and M.Eng in electronic engineering and an MSc in telecommunications engineering. He's a member of the IET and a chartered engineer. And Andy has kindly agreed to talk to us tonight about IoT architecture from an end-to-end perspective. So, Andy, over to you.
Brilliant. Thank you, Kevin, and thank you for the opportunity to present tonight. So let's go straight into it. So the first thing I wanted to start with around what is meant by Internet of Things. So to me, Internet of Things is around connecting an ecosystem of things, devices and applications. For example, an air sensor, an IoT air sensor. And this may include internet connectivity and support human interaction. The other term you may hear talked about in this space is machine to machine. And this is a bit different. It's about devices talking directly to systems and other machines without human interaction. So both of these cover the whole range of device scenarios and IoT scenarios, from household appliances, port cranes, manufacturing robots, transport logistics, asset tracking, remote healthcare, and to air quality sensors, even in smart cities. So why is IoT important for the future? Well, we only have to look at industry analysts. They are forecasting a huge growth in IoT machine to machine over the next 2 to 3 years. They're predicting worldwide over the next 2 to 3 years up to 30 to 55 billion IoT devices, generating up to 80 zettabytes of data between them. So that's the introduction. What I want to cover this evening is to start with one fundamental aspect I believe in, which is quantifiable customer objectives are key to any IoT project. I then want to walk through the building blocks of the IoT project, your devices, your connectivity, your device management, your IoT core, and data mining. Then I want to cover the aspects around the wrap of it, how you sell your IoT solution, the digital customer journey, how you secure it, how you make sure that you're following privacy by design, how you consider ethics aspects, and then how you do business continuity, and lastly, some industry alliances and standards which may be of interest. So starting with the first aspect, quantifiable customer objectives. Some IoT projects, it's known, that don't get beyond proof of concept or trials. And that's because they focus on just showing the latest technology, or some may say latest hype, rather than delivering true customer benefits. So to me, it's a foundation building block for any IoT project to define clear and upfront achievable customer objectives. For example, achieve X% port operation savings report through less crane and vehicle downtime. Another example might be save an NHS trust Y pounds through remote home diagnostics to speed up early discharge and reduce readmissions. Also, I think from an IoT perspective, it's key to always build into your design from the start scalability and longevity, given the high volume of IoT devices. So that's my foundation layer. And to cement this, a couple of examples of where you've got objective and focused trials and capabilities. The first one is a BT activity with Innovate UK as part of the Robot Highways project. And here, this is the use of IoT and robotics in smart agriculture. And this has a clear objective around driving automation, increased efficiency and sustainability. Another example of a focused trial and capabilities is where one of the BT partners has used a combination of IoT devices and AI capabilities to achieve energy savings of between 5 and 15% across a range of industries, covering glass, steel, cement and automotive. So that's the first layer. Then moving on to devices. So you've got your IoT device, but then you're moving into the key starter questions for me around what will drive your device type. And the questions here you should be asking yourself is, how will your device be powered? Will it be mains powered? Will it be battery powered? What are your radio coverage requirements? A personal network, home network, wide area network? How chatty is your data protocol? Daily, hourly updates or real-time streaming? How long do you expect your device to last for in the field? 2, 3, 5 years, 10 years? For example, you've got this water meter. It's going to be in the ground and battery powered for 10 to 15 years. So this needs a low power connectivity solution with deep coverage, such as Narrowband IoT or LoRaWAN, combined with a lightweight data protocol, which only collects data hourly or daily. Contrast that with a home security video camera, which can be mains powered or rechargeable battery, and only requires in-home coverage. So for this, Wi-Fi connectivity may be the answer with a real-time streaming protocol. So that's some of your starter questions for devices. Then once you've chosen your device, how is it going to pass back the IoT data to the cloud? And before I delve into the protocols, I just want to cover some architecture options here. The first one is publish and subscribe. So here you have your devices, and they publish data to a broker. And clients subscribe from the other side to that broker. And then the central broker publishes the data to the clients. And the broker, because of this, does not need to store the data. And it's asynchronous, and MQTT is one example of this. The next scenario is route and queue. Similarly, here you have devices. They publish the data to the broker, but this time the broker has the option of fanning out the information to the clients, rather like IP multicast. Or the clients can ask for the information to be pushed to them, or they can fetch it. So this is different So it has an asynchronous and a synchronous option. And AQMP is one example here. Then the last example is post, where you have the devices and they simply post to the client. And that's synchronous again, and you've got HTTP post is one example. So looking into your data protocols here, your IET data management protocols, there's a good selection of protocols exist. And your choice of these protocols is very much down to your data collection frequency, the size of the data, your device CPU, your device battery life, your reliability requirements, and your security requirements. So let's walk through them one by one. The first one is advanced messaging and queuing protocol. This is synchronous and asynchronous, and it's message-based. And it comes with the option of queuing, multicast, and request and reply options. And it supports reliability acknowledgements. So it's more on the high performance, and it comes with security options and works over TCP/IP. Next one is you've got message queue telemetry transport protocol. This is asynchronous, and it's based on the pub/sub model, the publish and subscribe model. And it's aimed at scenarios requiring low bandwidth, low CPU, and power battery consumption. And it can be secured via TLS. Then you've got HTTP post. And this is synchronous. And it's a synchronous post-based approach. And it has larger header and messages because of this. Then you've got constrained application protocol. And this is UDP based. And again, this is aimed at scenarios requiring low bandwidth, low CPU, power battery consumption. Then you've got the data distribution service. And this is a real-time publish and subscription option aimed at the high-end IoT applications. And then you've got lightweight machine-to-machine protocol. And this is again aimed at scenarios requiring low bandwidth, low CPU, low power, low battery consumption. But it's slightly different because this can be run over UDP, TCP, or SMS. And it also includes device management functions. And then lastly, you've got the extensible managed messaging and presence protocol. And this is real-time based and provides structured and extensible data options. And alongside these, you have several device management protocols, such as the lightweight machine, the OMA device management, and broadband forum options. So that's a quick run through of your device management protocols. For mobile devices, another aspect you need to consider is your SIM. SIMs have evolved from the physical SIM that we all know. You've also now got the option of an embedded SIM. And this is where you have the SIM is embedded via a chip in your device. And then for somebody that's trialing and going for some devices, you can take it a stage further. Rather than having a separate chip on your device for the SIM, you can integrate that. Have an integrated SIM where the SIM is integrated into your main device system on a chip. So clearly, eSIM and iSIM offer optimal provisioning because you don't have to pay for the cost of the SIM and truck rolling it out to devices, and you can quickly manage it because it's already on the device there and manageable over the air. The other aspect you need to consider from a mobile perspective with IoT is NISDNs, effectively your mobile number. If you've got a limited number of mobile number ranges, if you allocate a MISDN to an IoT device or machine-to-machine device, which is data only, you risk wasting that because you're just doing it for the provisioning purpose. It's never used because it's not a phone device. It doesn't need voice or SMS if it's data only. So I'd recommend the use of MISDN-less or pseudo-MISDN for data-only devices, so you could preserve your number range. And then for IP-enabled devices, we all know that IPv4 addresses are becoming more and more scarce. So clearly it's desirable, if you've got an IoT device, you'd want to be dual v4, v6 at the very least, and highly desirable to be v6 only. So those are some wider SIM naming and numbering considerations. So you got your device. The next thing is how you're going to connect it. So the options you got here is a personal area network, like so Bluetooth. And then you've got your home and your local area networks, like so Wi-Fi, Zigbee, Fred, Matter. Touching on Matter a bit more, it's a relatively new standard coming out of the Connectivity Standards Alliance. And they issued the first version of this in November last year. And it's around providing a solution to do seamless and secure connectivity between smart devices, other devices, networks, and the internet. And it's built on top of the IP protocol, but also supports multiple radio options. And here's an example of a chip which supports Bluetooth, Zigbee, and Fred radio and Matter capabilities. And I can show you these devices at the end of the talk. The other technology got in this space is, of course, Z-Wave as well. Now, can anyone guess in the audience here in the room, there's one I've missed out, which you could argue sits between personal area networks and home networks? Anyone guess at the technology I've missed out? Okay, then what I've missed out is ultra-wideband in terms of asset tracking. So I had a debate with my colleagues yesterday around whether it was personal area network or local area networks. And we said it really sits between the two. I didn't want to overcomplicate the slide, so I thought I'd voice over it. So moving on to wide area networks. The first thing is you've got your traditional mobile networks, 2G, 4G, and 5G. And with 5G, you've now got the option of a private or a public network. The difference between the two is public is clearly, it's a mobile network open to everyone. A private network is a network capability for a particular organization. For example, a 5G university campus network, just for that university campus to use. And it provides 5G in a way which is segregated and a controlled customer experience. Then you've got your IoT technologies, Narrowband IoT, Cat-M1, Cat1bis, the emerging RedCap. I'll cover these all on the next slide. And you've got your license exempt spectrum solution, LoRaWAN. We also shouldn't forget satellite. Satellite's becoming more popular now. In terms of satellite connectivity, you've got the option of a satellite to a gateway, and then from your gateway to your IoT devices, or even direct from the satellite on some startups straight to your device, because the satellites are supporting Narrowband IoT and LoRaWAN connectivity. So delving into the mobile ones in a bit more detail. Starting with the 5G, you've got two flavors here, standalone and non-standalone. What I mean by standalone is 5G radio connected to a 5G core, cloud core. What I mean by non-standalone is 5G radio connected to a 4G LTE core. If you've got an IoT application which is looking for ultra-reliable low latency, a real-time application like autonomous vehicle driving, extended reality, drones, then you're looking for something which is ultra-reliable, low latency. So 5G standalone is your answer. If you're looking for high-performance applications needing voice, mobile, and data support, then you've got 5G non-standalone, traditional 4G, and then you've got in the middle 5G RedCap. Now, this is an emerging technology out of 3GPP release 17, and it's sort of aimed at addressing the applications which still need a good degree of low latency and reliability, but don't need so much high speed, because you can see the speed for it is up to 50 megabits per second. Then you've got the IoT options. You've got Cat-M1, which gives you voice and data up to 10 megabits. That's great for things like healthcare and wearables. Then you've got Cat1bis, which is a version of LTE, but just a single antenna, which means you've got lower costs on your device. And then if you've got applications where you really need deep coverage and you need large range and low data rates and extremely long battery life, such as a water meter in the ground, then you should be looking at narrowband IoT from the cellular option and from the unlicensed spectrum, license exempt LoRaWAN. And narrowband IoT gives you data rates up to 127 kilobits per second and LoRaWAN up to 50 kilobits per second. If you go with a mobile option, there's several connectivity options you've got in building your IoT network. The first one is a public APN. And this is where you have a public path from your device. You share a path with all other machine-to-machine IoT traffic for that operator through the mobile core and across the internet. So that's your public APN. But you can also buy a private APN, where you have a dedicated path across the mobile operator's core, and it's often coupled with a data VPN, which is a secure IPsec tunnel across the internet, and it lands your customer data on an application or cloud. So that's your private APN and data VPN. Then you've got several SIM options. You've got the option of a single SIM when you're disconnecting to one operator. Then you've got the option of dual SIM, that if you want that coverage, resilience, and reliability for an application and device, you can have the option to connect to two operators and have that fallback. So that's the dual SIM approach. Then you've got the roaming approach, where you can connect to multiple operators. And then with narrowband IoT, the industry standard, gives you even more options. So on narrowband IoT, if you're not so worried about throughput and data rates and also battery life, then you've got the IP data delivery. But if you want to conserve that battery life and you've got a device with a really low power CPU, then you've got the option of non-IP data delivery. And then LoRaWAN, such as this LoRaWAN PIR sensor, motion sensor. You've got your LoRa devices. They talk to a LoRa gateway. LoRa radio this side, Ethernet out this side. Then you can backhaul it across mobile or broadband. Then you land on the LoRa network server. LoRa has two layers of encryption. The first one is from your device to your network server. But you can also do application encryption, where you can encrypt it from your device and your application through to an application server. And you can have a different application server for each customer and application. So that's the LoRa approach. So you've got your devices, you've got your connectivity. Then the next thing you need to consider is, how are you going to manage these thousands of IoT devices you're going to have on the network? So the first thing you need to consider is the device management. How are you going to manage this water meter or this camera? How are you going to update it in terms of over-the-air firmware updates, security updates, configuration? So you need a device manager. Then the next capability you need to do is manage any application on the device. So you need that capability there. Then the next thing you need to remember, if it's a mobile device, you've got a SIM in there or an eSIM. So you need a solution to manage your thousands of SIMs and eSIMs in terms of activating them, ceasing them, knowing the billing records, the usage records, knowing what devices have what SIMs. And some aspects which might help you here is the use of digital shadows. This may aid device management in the future. A digital shadow is a virtual representation of a device available through an API. That's another aspect to read up on. The other consideration is you might have lots of proprietary device management. So for each device vendor, you might have a device management solution. So you need to stack up lots of device managers. So one option here is to try and go and drive towards a common device management standard to simplify that. And of course, the goal is you want to move towards zero-touch onboarding, when the devices just connect simply and work. So that's device management. So you've got your devices, you've got your connectivity, you're managing your devices. Next question is, where are you going to land your data? where are you going to ingest this IoT data? So the key questions you need to be thinking about here are, do you have any security requirements? If you're a manufacturer, do you have a security requirement that your data needs to be kept on site? Do you have any latency requirements? Do you have any data volume considerations? So the options you've got are at the customer edge. So for a consumer application, you might want to ingest the data on a home hub. For a 5G private network, you may want to ingest the data on a site server attached to that 5G private network. Then the next option is if you're working with a network operator who's got a private cloud, you might want to land the data on their network cloud, which could be on exchange sites or data centers. You might want to land it on your own data center. Then the next option is you might want to land it on a public hyperscaler cloud. Or you might want to go for a hybrid approach, where you can ingest the data on the edge and also in the cloud. Get the best of both worlds. So once you've chosen where you're going to land and ingest your data, the next question is, who are you going to partner with to do your IoT core? Is it going to be a hyperscaler? You're going to go open source, a system integrator. And the questions you need to ask around the data requirements are, how are you going to ingest the data? Then what are you going to do with the data? Are you going to do simple and basic workflow logic? If that, then this. Or are you going to do more advanced machine learning? If you've got huge volumes of data, might you want to do a bit of machine learning on the device or on the edge on a private network, so you can save the volume of data that you're pushing up into the cloud? What are your insights and key reporting requirements to meet your customer objectives? And how are you going to present those to your customers? Through APIs, customer portals, and alarms? And do you want to use digital twins, like a virtual model of the real world data point? And then the other question you've got is, if it's standard reporting requirements, you can probably meet it through your hyperscalers, your open source, or your system integrators. But if you crunch in IoT data, say for a healthcare device or energy consumption, you may need to partner with an expert application partner who's expert in that particular field. So that's another consideration. Then you've got to think around data mining and data sharing. Is the data you're collecting is focused on a particular application? So for example, smart utility meter information, you're crunching and getting that data just for billing. So you can do basic application analytics on it just for that purpose. Or do you need to do data mining, where you're combining that information with other sources and potentially artificial intelligence to gather additional information, such as usage trends? So that's another key question. Then you've got the question, is that IoT data just for one particular customer and entity, like an electricity firm? Or do you need to share that data with multiple partners in a secure way? And a good example of a multiple partner solution is consider a smart cities. A smart city might have traffic flow sensors, weather temperature sensors, parking bay occupancy sensors, traffic flow information, lots of information from different sources. And you just share it with different entities, local authorities, local transport operators, local big companies, consumers and end users, lots of people you want to share with. If you don't have a data sharing concept, then you may risk having questions like, how do you share? In what format? When? How do you secure it? Moving to a data exchange, data sharing model gives you the ability to share that data in a structured way, in a secure way across multiple entities. So that's another aspect to consider. So far I've considered all the building blocks for your IoT solution: your device, your connectivity, your device management, where you land on the data, how you mine that data, how you report it, all the technical building blocks. Now I want to touch on how do you sell that and what do you need for your digital customer journey and business support system to sell it. So the first call out here is, given the huge volume of IoT devices in the future, the digital customer journey wrap here must be modular and it must be agile. One particular model we use to map this out is known as LBGUTS, which stands for Learn, Buy, Get, Use, Pay and Support. So let's walk through each of the areas. So the first area is Learn. So here your IoT customers need to be able to learn, simply learn about the IoT propositions and services that you're selling. So here the answer is to make them all available through clear digital channels, websites, apps, etc. Then next one is Buy. Your customers need to be able to buy it in an easy way. So here you need clear IoT propositions and services. And it must need to be easy for customers to purchase a range of IoT products and devices, ranging from a starting point of connectivity only, then connectivity plus your device management, then connectivity plus device management plus data reporting. And then lastly, you may want to layer on top of that data mining, data sharing. So you've got a good buy strategy. The next one is Get. Here you need to make sure that your customer has a simple and seamless process for configuring customer SIMs, getting the devices, enabling the IoT platform, portal and capabilities, and ensuring prompt shipment. And the key goal here is also to simplify working out of the box and zero-touch onboarding. This works as soon as it gets to the customer. And if your customer interaction is needed, make it simple. Like how on this water meter, there's a QR code on it. Scan that QR code to aid the device setup. And of course, keep your customer informed on the progress in terms of configuration stage and shipment stages. Next category is Use. So here it's got to be simple for your customers to use the IoT service. So again, it's key to have a digital channel here, app and web experience, for customers to simply order SIMs, manage their SIMs, manage their devices, see their usage, see their billing. And if you've got corporate enterprise customers, support single sign-on so they can log in within their enterprise credentials. Then the next one is Pay. So here you need a simple and reliable and flexible billing solution to meet the future high volume demands for IoT. So you need to consider per device billing, or given the huge volume, you might have 10,000 devices. Do you go for a bundle in terms of usage based on that bundle? How do you do the mix of voice, data and SMS billing for IoT? How do you weave in roaming aspects? And then lastly, you've got your S for support. So here you've got the ideal ask is to have an app, web, SMS and email alert for any service issues. Clear support model so customers know where to contact with issues, and an agreed service level. Then the next area I want to cover is security by design. Many conference presentations I've been to last year called out that IoT security is behind IT security. So if that's true, what does IoT need to do to catch up? So to me, one way where you can catch up is making sure security is considered by design from day zero product development for IoT. So some tips here on what you need to consider potentially. First one is device security. Make sure the data on your device is secure. Then look at data security at all levels, in your network, in your application, and all the APIs. Then look at your cloud data center and your data center security. Look at the opportunity to proactively detect and mitigate threats. So look at traffic and see what is normal. And then as soon as you spot anything abnormal, you can alert on it, rather than just encrypting traffic at the network and application layer. be proactive around detecting and mitigating against threats. Then the next one is make sure your firmware updates and configurations over the air are secure and certified. Move away from traditional credentials like username passwords to adopt principles based on zero trust, such as on-chip credentials. Also have a look at quantum compute and consider the aspects and benefits of quantum compute, and also what this can mean in terms of the impact of a post-quantum world on existing devices and current protocols, especially if there's a long longevity of IoT devices. And of course, do regular software code reviews and security penetration testing. Also want to cover 2 security acts recently that you should be aware of if you're designing IoT solutions. The first one is compliance with the Product Security and Telecommunications Infrastructure Act. And this got royal assent back in December 22. And it covers mandatory security requirements for consumer connectivity products sold in the UK, including IoT devices. And this covers aspects such as vulnerability disclosure policies, a ban on default passwords, and also a must-have in terms of transparency on how long a supplier will provide product security updates for. I've included the link to that. The other one worth noting is the Telecommunications Security Act and associated regulations of code of practice. And the other great source of recommendations in the IoT security space is the IoT Security Task Force guidance. They've got a great set of guidance around IoT security. One aspect which goes hand in hand with security is privacy by design. And first, a caveat to this one. I'm a techie, so not a lawyer. So the above and what I'm going to cover here is purely informal insights to reflect on. And it's not a comprehensive list of what should be considered. Companies, and naturally companies and individuals should seek their own legal and data protection privacy advice. However, the key things you need to consider here from a data protection and privacy legislation are the GDPR Act and also the Data Protection Act 2018. And if you're handling marketing and cookies and usage data, you also need to be aware of the Privacy and Electronics Communications Regulations 2003. So the key aspect here to consider is, does GDPR apply to any of your IoT machine-to-machine data? And the answer is, could be yes, if it's linked back to personal information and to an individual. And you need to remember that a unique IP address, an equipment identifier, or MAC address are classed as personal information. So for example, this water meter, some people might say, oh, water meter reading, that's not personal information. But this water meter has a unique serial number. If that serial number is then linked back to a unique user, an identifiable person, that makes it personal information and applies to GDPR. So some privacy aspects to consider, again, from the outset of your IoT project. Follow the principle of data protection by design and default. First thing I would do here is have a data protection impact assessment to qualify what data protection risks you might have and how to mitigate against them. So the first thing I would do is draw out an end-to-end data flow. Capture what data you're collecting, what it is, why you needed it, where does it originate from, how's it being transmitted, where's it being processed, where does it land, where's it at rest. Then take that diagram and layer it up. How's the data encrypted, both in transit and rest? And don't forget, you've got data on your device. So how's that encrypted? How to give your customers the opportunity to delete that data if they're going to resell it. Cover your data centers and backups. Also consider what countries you may be exporting the data to. So where are your data centers being based? Where are your development and support teams? Then consider, can you minimize your risk? Can any of that data be anonymized? Can you minimize the amount of data you're collecting? And assess what technical and organizational security measures you can put in place, like the level of encryption. Also, it's key to have a data retention policy. How long are you going to store that IoT data for? And then how are you going to securely delete it when it's no longer required? And then lastly, you need a data subject access request process to make sure you can authenticate if customers request access to their data. So there's lots of privacy considerations to reflect on as well. The other aspect you need to consider from an IoT perspective is ethics by design and environmental impacts. Starting with ethics, IoT has a huge opportunity to transform customers' lives and also industry for the better. However, it's important IoT products are developed with ethics in mind to build public trust in the technology, especially as IoT solutions may include aspects such as artificial intelligence, CCTV security, and healthcare aspects. So the advice here is, as part of your IoT project, create a set of guiding responsible technical principles built on potentially, have a look at the building them on the UN guiding principles on business and human rights. And if your products like to involve children, also include the child rights. For example, ensure that IoT technologies are developed, brought, and sold in a way that benefits people and minimizes harm. And take care to avoid and protect against tech misuse. So an example of this is, one capability is Wi-Fi Sense, which can detect presence in the home. It's effectively like an RF sense, like a radar capability using Wi-Fi. So it can obviously give great capabilities for home security in terms of detecting people's presence, and also healthcare in terms of detecting anyone falling. But you need to consider the abusive misuse risk around tracking presence. So there's a careful balancing act. Also, if you're using AI in IoT, ensure diversity is considered in your data set, your algorithms, alongside data quality. And lastly, IoT has a huge opportunity to assess in sustainability and energy aspects. And this could be from building management systems to smart cities. The other aspect you need to consider is business continuity. If your IoT applications are supporting critical applications, services, you need a business continuity plan. So you need to consider the level of resilience you need in the data center and the cloud. Do you need geographic redundancy? Do you need multi-cloud provider resilience? Do you need redundant and backup components? Do you need data backup policy? And of course, test your business continuity regularly. And then standards. Clearly, the recommendation is try and build your IoT solutions where feasible off open standards. And some key standards and industry alliances you may want to look up in the IoT space. 3GPP is the obvious one from the mobile perspective, likes the Wi-Fi Alliance, the Connectivity Standard Alliance, which is defining Matter and Zigbee, Z-Wave Alliance, Bluetooth, Thread, obviously again GSMA for the mobile, one M2M for IoT machine to machine, OMA, Broadband Forum for broadband side of IoT devices, Security Foundation, IoT Security Foundation for security guidelines, and of course ISO for information security management. So I want to wrap all of this up with an example of an end-to-end IoT solution. So this is something we deployed in BT for monitoring EE remote sites. Starting with my fundamental first thing was around the customer objective. So the customer objective here is proactive site monitoring, improved customer experience and cost savings through reduced downtime and site visits. So next layer up was the devices. So here we've got a device, door sensor. We've got a manometer for measuring the wind strength, temperature sensor, and power monitoring probes. All of these connecting to a BT IoT smart asset hub. And then that connects back to our BT IoT platform over EE, 4G and 5G connectivity. In terms of your IoT device protocol, here we were using MQTT and SMP. Then we're landing into the IoT platform, which is built off AWS capabilities. We're ingesting the data, we're analyzing on it, we're acting on it, and we're sharing on it. And we're managing the data, and we're managing the devices. And then we've got a customer view for our BT users to show with them the state of that location in terms of temperature, air conditioning, security. And we've had some scenarios where it's actually helped us and delivered on that objective. Because there was one day when we spotted the temperature was really starting to go high, and we were proactively able to act on that by sending an engineer out to the site and addressing it before it caused any customer affected issues or cost. So that's a real-time example. I've tried to keep the presentation technology neutral and from an industry perspective, but just wanted one slide around what we're doing in BT around IoT. And my colleagues in BT Business Division X would love to talk to you about this if you're interested and want to discuss more. And the things they cover are connectivity, global asset tracking, monitoring, vehicle telemetry, condition-based monitoring, remote operations, 5G immersive spaces, digital vision and AI. And thank you very much for your time.